Hello everyone and welcome once again to Prof. Dan Tutorials. Please kindly click on the subscribe button. Thank you. Our topic today is differentiation from first principle. I'm going to use an example to explain the concept of first principle as it relates to differentiation. Okay, let's look at this example. Given that y equals root of x, we want to differentiate y with respect to s. There are a couple of steps we're going to pass through, and the very first thing we are going to learn is what we call increments. We are going to make an increment on these two variables. And how do we achieve that? You have y, make an increment, and that is denoted by this symbol like a triangle. So increment in y equals root of the variable x plus its increment. So you increase both variables. From here, make the increment in y subject of the formula. And why are you doing that? Because at the end of the day, we want to get something like this out. Increments in y divided by increments in x. So if I do that now, I have increments in y equals x plus increments in x. When y goes to the right side, it becomes minus y. My increment in y is now root of x plus increments in x minus. Remember that this y from the question is rightly given as root of x. So anywhere we say y, we replace it by root of x. The next thing is we want to bring something like this out. Increments in y over increments in x. So by manipulating this, we say divide both sides by increments in x. And that becomes increments in y over increments in x equals what you have at the right side, x plus increments in x minus root of x, all divided by increments in x. So gradually we are getting something like this. So the next step is what we call limits. So you need to limit this increments in y to increments in x. So we have increments in y to that of x as we limit as the increments in x tends to 0. So our interest is on the whole of the right hand side, root x plus increments in x minus root of x over increments in x. Okay, so whenever you are doing limits, certain principles needs to be applied. Roughly, let's put increments in x as 0 into this expression here. We are going to be left with root of x plus 0 minus root of x, all divided by increment in x is 0. So this leaves us with root of x minus root of x, all divided by 0, which in turn gives you 0 over 0. So this is a no-go area. We can't do this. That is why I said some principles are applied when you are limiting. So what can we do to change the whole situation? Very simple. If you remember what we call rationalization of sort, if you remember rationalization, if you remember the concept of rationalization, that is what we are going to use now. And to do that, in the numerator, let's look at this. In the numerator, we have root of x plus increment in x minus root of x, and in the denominator we have root of x. So the concept of rationalization here, we are going to rationalize the numerator. In the numerator, it is root of x plus increment in x minus root of x. Okay, and for you to rationalize, you need to recall what we call conjugates. So conjugate is the opposite of this. So the conjugate of this is going to give us root of x plus increment in x plus root of x. So negative has turned to positive between the two terms. That is, this is its conjugate. So the concept of rationalization now says you need to multiply both of this, the fraction, the entire fraction, that is root of x plus increment in x minus root of x, all divided by increment in x. So we want to rationalize this. So it says multiply both the numerator and the denominator by the conjugate of this numerator. Okay, so we have root of x plus increment in x plus root of x, all divided by the same thing, the conjugate, root of x plus increment in x plus root of x. So of course, if you look at this, the whole of this, the whole of this, and the whole of this, if you divide, will give you 1. So it has really not changed anything. So now what do we do? Multiply both ups, the numerator and the denominator. If we do that, that means that this term is going to multiply this, and at the same time it will also multiply this. So and remember, in mathematics, if you have root of a number, let's say a times root of the same number, is going to give you that number. It's as simple as that. So that means that the root of x plus increment in x multiplying root of x plus increment in x is going to leave us with just the x plus increment in x. So that's the very first thing. And the second thing here is that we have this also, root of x plus increment in x multiplying root of x. So that's going to leave us with plus, we can have root of x is multiplying root of x plus increment in x. So now we are left with this. Let's use the second term to expand. So this also multiplies the first one, and it also multiplies the second one. So if it multiplies the first one, will be have minus root of x multiplying the whole of root of x plus increment in x. And the second one now, first is negative, multiply positive will give you negative. Root of x multiplying root of x is going to give you x. Remember this. Okay, so everything divided by, we need to expand this also, the denominator. Now this multiplies this, and it also multiplies the second one. So that's going to leave us with change in x multiplying the root of x plus change in x, and we have plus increment in x multiplying the root of x. So if you look at this, we can figure out that the whole of this term, we cancel out the whole of this term. Also, the whole of this term x minus x we also cancel out. So we are left with change, or let's say the increment in x at the top numerator divided by, at the denominator, between the first term here and the second term, something is common, and that is increment in x. So let's factorize that. So taking increment in x out, the first term will be left with root of x plus increment in x, okay, plus increment in x factorized from the second term, we are left with root of x. Okay, and as we have this, we can see that the numerator and the denominator has something common which can cancel out. So we are now left with 1 over root of x plus increment in x plus root of x. Okay, so all we've just done is to rationalize. So we've rationalized this to get this. So this is our interest now. Limits as change in x tends to 0, the whole of this are increments in y to that of x for 1 divided by root of x plus increment in x plus root of x. So this is our new term. So as we put increment in x to 0, this is going to leave us with 1 over root of x plus 0, okay, plus root of x. Now take note that the limits of the increment of variable y to that of variable x as the increment in x tends to 0 is what we call the differentiation. So that is dy dx. So this is leaving us with dy dx is equals to this. So our dy dx will now be 1 divided by root of x, as x plus 0 is x, plus root of x. And that is going to give us 1 divided by root of x plus root of x will give us 2 root x. So the differentiation of variable y with respect to x will leave us with 1 over 2 over root x using first principle. Alright guys, that's going to be the end of this tutorial. Please kindly subscribe to my YouTube channel, Making the Complex Simple. Thank you and have a nice day.